Third one, structure and geometry of hydronium ion. Structure and geometry of hydronium ion, okay. H3O plus hydronium ion, okay. Hydronium ion is found by donation of one electron pair, lone pair, and oxygen atom in H2O to hydronium ion, okay. Then oxygen, one hydrogen, and two, 4, okay, and H positive, okay. Arrow mark of H, oxygen, hydrogen, and two lone and one lone pairs, and hydrogen. This is H3O plus, okay. Hydronium ion is found by donation of one electron pair. Hydronium ion is found by donation of one electron pair on oxygen atom in H2O to hydrogen plus ion, okay. In hydronium ion, the central atom oxygen has 4 electrons. In hydronium ion, the central atom oxygen has 4 electrons. Oxygen has 4 electron pairs in valence cell. Out of 4 electrons pair, there are 3 bonded electrons pair and 1 is lone pair. There are 3 bonded electrons pair and 1 is lone pairs, okay. Oxygen atom in H3O hydronium ion is sp3 hybridization. Which hybridization? sp3 hybridization. 2 sigma bond oxygen hydrogen. 2 sigma bond oxygen hydrogen is found by the overlap of singly filled sp3 hybrid orbital on oxygen atom and 2 hydrogen atom with unpaired electrons. 2 hydrogen atom with unpaired electron. One dative bond, coordinate bond. One is coordinate bond. One is coordinate bond is also found by donation of a pair of electrons from oxygen atom to hydrogen atom, okay. 1 is 0. This bond is oxygen to hydrogen ion. Here H2O acts as a Lewis base, where H2O acts as a Lewis base, while hydrogen positive ion acts as a Lewis acid, okay. Hence coordinate bond is found. Oxygen 2s and this is 2s 1, 2, 3 and 4, 5, 6. This is hydrogen positive ion, and this is hydrogen, and this is hydrogen dative bond. This is minus. This is minus dative bond. Dative bond. Due to sp3 hybridization, structure is tetrahedral. Structure is tetrahedral. Okay. Structure is tetrahedral. Okay. Due to sp3 hybridization structure is tetrahedral, but the presence of one lone pair. Of electron distorts the structure, hence H3O positive. That means hydronium ion has trigonal pyramidal shape. Okay, trigonal pyramidal shape. This is the trigonal pyramidal shape. Hydrogen ion, hydrogen, and this is a two lone pair. This is two lone pair. Okay, two lone pair. Okay, this is two lone pair. Okay, oxygen. And the structure of hydrogen. This is the structure of hydronium ion. Okay. Geometry of sulfur tetrafluoride. SF4. Geometry of sulfur tetrafluoride. SF4. Okay. Geometry of sulfur tetrafluoride. In sulfur tetrafluoride, the center atom system or the electronic configuration of sulfur is given by S16 is 1s2, 2s2, 2p6, 3s2, 3px2, 3py2, and 3pz1 and 3d0. Okay. We will be talking about 3 orbit. Number 3 orbit. Okay. This is the 3s2. This is 3s2, and the electron is filling as. Okay. And this is the 3p4. 1, 2, 3. Okay. 1, 2, 3, 4. Okay. And this is a d orbital. 3d 0 orbitals. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And S in ground state. Sulfur in ground state. This is sulfur in ground state. Okay. Ground state. And sulfur in the first excited state. Is also converted as like this. Sulfur 3s2 in this sulfur is converted also 3s3, 3p3. Okay, 3p3, and only 3 electron present in p orbital, and 1 electron is moved to d orbitals. Okay, this is also converted in 3d1, 1, 2, 3, 4. This is 1. This is the sulfur in first excited state. Okay. And after hybridization, the sulfur in sp3d hybrid orbitals, how to like this. Okay, this is 7 sp3d hybridization. Because 1, 2, 3, 4, 5, 6. Okay, sp3d hybridization. sp3d hybrid orbital, and sulfur in sp3 hybrid orbital. And after hybridization, this is S3s 3p, 3d, 3d, okay, 3d, and one electron, and this is a hybrid electron is fluorine, and this is a hybrid electron of fluorine, and this is a hybrid electron of fluorine atom, okay, and this is a hybrid electron of fluorine atom, okay. This is a SF4 molecule, SF4 molecule, okay. Sulfur has 4 half-filled orbitals. Sulfur has 4 half-filled orbitals. Sulfur has 4 half-filled orbitals. 1, 2, 3, 4 half-filled orbitals, and 1 lone pair in its first excited state. This is 5 atomic orbitals hybridized to form 5 sp3 hybrid orbitals. 5. 3, 1, 2, 3, 4, 5. Okay. This is a 5. These 5 atomic orbitals hybridized to form 5 sp3 hybrid orbitals. One hybrid orbital has a lone pair. The remaining 4 hybrid orbitals contain 1 electron, which forms 4 sigma bonds. Bonds with a 2pz1 atomic orbitals of 4 fluorine atoms. Okay, 4 fluorine atoms. 4 fluorine atoms due to presence of 4 bonds pair and 1 lone pair hybridization in SF4 is sp3d. Hence, structure of SF4 is trigonal bipyramidal. Bipyramidal, okay, trigonal bipyramidal, but due to presence of 1 lone pair in equatorial position, SF4 molecule has distorted trigonal bipyramidal shape, okay, trigonal bipyramidal shape, okay, trigonal bipyramidal shape, and lone pair occupies equatorial position, since in this case repulsion is minimum. Structure trigonal bipyramidal shape, okay, structure trigonal bipyramidal and shape distorted trigonal bipyramidal are unsymmetrical tetrahedral, okay. If you can show also the structure as this is the sulfur, fluorine, and fluorine. This is a double lone pair, and this is fluorine, okay, and this is sulfur, fluorine. This is fluorine, and this is fluorine. Okay. Okay. is the structure of SF4 sulfur. This is the structure of SF4. Okay, the structure of SF4. Okay, sulfur tetrafluoride. Sulfur tetrafluoride 1, 2, 3, 4. 4 fluorine tetra. Okay, structure of SF4. And next is the structure and geometry of chlorine trifluoride. And next is the structure and geometry of chlorine trifluoride. Fluoride. Okay, chlorine trifluoride. Okay, ClF3. Okay, Cl3F3 is an interhalogen. Okay, chlorine trifluoride is an interhalogen molecule in which chlorine is the central atom. The electronic configuration of chlorine is given as C7 arrow mark of 1s2, 2s2, 2p6, 3s2, 3p, x2, 3py2 and 3pz1. One of the electrons of 3py2 is excited to 3d orbitals, so that there are 3 orbitals which have unpaired electrons. These 3s, 3p and 3d orbitals mix together and form 5 sp3d hybrid orbitals. 2 of these orbitals are occupied by 2 lone pairs, while other 3 orbitals are half-filled orbitals. 3 unpaired electrons form bond with 3 fluorine atoms as a result of sp3d hybridization. Okay, and this is the 3s2 1, 2, 3. Okay, 3p5 1, 2, 3, 4, 5, and this is 3d 0 1, 2, 3, 4, 5. This is chlorine in ground state. Okay, and next 3s2, and this is 1, 2, 3. Okay, 1, 2, 3. Okay, 3p4 because 1 electron is moved in d orbitals. Okay, then 1, 2, 3, 4. 1 electron comes in d orbitals from p orbitals. Okay, then this is 3d1. Chlorine in first excited state. Chlorine in first excited state. Okay, and in next sp3 hybridization is how to. This is 1, 2. Okay, 1, 2, 3, 4 because 1 electron is moved in d orbitals. So 1, 2, 3, 4, 5. Only 1 electron. 3d1. Chlorine in sp3 hybrid orbit state. Chlorine. This is like this. Okay, sp3d. sp3d because chlorine chlorine in sp3d hybrid state, and this is sp3d hybridization, okay. And after hybridization, this is 1 2 3 1 2 3, and in d orbitals 1 2 3 4 5, and this is d orbitals, okay. And the hybrid orbitals F fluorine, sorry, this is clear, not fluorine, okay. Also fluorine, this is fluorine, and this is fluorine, okay. This is fluorine, ClF3, okay, molecule, okay, ClF3 molecules, okay. As the hybridization is sp3d hybridization, okay. Structure of ClF3 is a trigonal bipyramidal with two positions occupied by ion pairs. Structure. Trigonal bipyramidal, and shape is T-shaped. Bond angle are almost 90 degree, approx 87.6 degree, okay. The distortion is due to presence of two lone pairs. Because this figure is also as like this is chlorine and this is fluorine, and double lone pairs here present here. 1 2, and this is fluorine, okay. And the structure as like this, okay. And the shape is also T-shaped. Fluorine, okay. Because bond angles are almost 90 degree. Approx 87.6 degree. The distortion is due to presence of two lone pairs. VRF3 has also sp3d hybridization as that of ClF3. VRF3 has sp3d hybridization as show ClF3, and its shape is also T-shaped, and both are shaped is also T-shaped. Structure of ICl2, structure and shape of ICl2, okay. Structure and shape of ICl2. 1 minute. Structure and shape. Shape of ICl2. Okay. In ICl2 ion, the central atom is iodine. The electronic configuration of iodine is I53 is 1s2, 2s2, 2p6, 3s2, and 3p6, 3d10, and 4s2, 4p6, 4d10, 5s2, 5p5, and 5p0. Iodine negative ion is remark of 5s2, 5p6, 5t0. One of the electrons of 5p, one of the electrons is 5p orbitals is excited to 5d orbitals, so that there are two unpaired electrons. These 5s, 5p and 5d orbitals mix together to form 5sp 3d hybrid orbital. sp3d hybrid orbital is also the three of these are occupied by the lone pairs, while other two are half-filled. These half-filled hybrid orbitals are used to form two iodine-chlorine bond. Iodine-chlorine bond. Hence, ICl2 negative, ICl2 ion is formed by sp3 hybridization. It has two bond pair and three lone pair. It has two bond pair and three lone pairs. Two bond pair and three lone pairs of electrons. The three lone pairs of electrons are directed towards the vertices of the triangle, while the two bond pairs lies perpendicular, one above the plane and other below the plane of the molecules. Thus, the shape of iodine ICl2 ion is linear with bond angle 180. Okay, bond angle is 180 degree. Okay, bond angle is 180 degree. Structure. This is iodine, one lone pair, second lone pair, and this is third lone pair. This is third lone pair, and okay. This is iodine atom. This is one lone pair. This is second lone pair, and this is third lone pair. This is chlorine. This is chlorine. Okay, and negative ion equal to Cl iodine linear. Okay. Structure is trigonal bipyramidal. Structure is trigonal bipyramidal. Shape is linear. ICl2 ion has the structure of ICl2 ion is also determined as follow. Total valence electron is 7 plus 7 multiplied 2 plus 1 equal to 22. Okay, and number of bonds so equal to 2. Electrons used in octet formation. Electrons used in octet formation equal to 2 multiply 8 equal to 16, and number of lone pairs equal to 22 minus 16 whole upon 2 equal to 6 upon 2 equal to 3, and total orbital needed and total orbital needed. Total orbital needed 2 plus 3 equal to 5. Hybridization is sp3d hybridization and structure is trigonal bipyramidal. Structure is trigonal bipyramidal. Okay. Shape is linear. Shape is linear due to presence of three lone pairs. Okay. This heading is completed, and next is we will be study about the structure and shape of some covalent molecules. Okay, and after that we will be study about molecular orbital theory, MOT, or Hund-Mulliken theory. Okay, thank you.